So we're going to start on the next topic within probability, which is sets. Now you won't have come across this before and a lot of it is going to be brand new. The first new bit that you need to learn is the new notation. So first thing is a union. Now that is represented by a U shape. This means that it is in one set or the other or both. The next is intersection, and it looks a little bit like an N. This means it has to be in both sets. Next is complement. It's a little dash next to a letter usually, or the set, and it means that it is not in it, so everything that is not in that set. When you have the union or the intersection, we can use or and. So if you think of union, so it's in one set or the other or both, the important word there is or. Intersection has to be in both, so it's in set A and in set B. Here's a collection of all the different notation you might get. So we've already looked at intersection, union, and universal set. Also complement of set A. Now another one which comes up quite a lot is this. So a little circle with a line through means empty set, so 0. Now you need to be able to shade in regions on a Venn diagram based from a set. So, for example, if we wanted just set A, so if it was in set A, we are just going to shade in everything that would be in set A. So you can see I've shaded in just the circle A, and it also includes the little section which crosses over with B because it is still in A. The one underneath, A complement, means everything that is not in A. So I'm going to pretty much be shading the opposite of the one above. So everything that is not in that circle of A. Okay, so what does this mean? If I read it as a sentence, it's A union B, but instead of union, we're going to use the word or. So it means that it's in A or in B. The easiest way to do these is to think of them as two separate questions. So first you're going to shade in A, and then you're going to shade in B. So you can see that we are looking for anything that is in A or in B. So it's both the circles shaded in, including the centre. The one beneath it is exactly the same, apart from it's the complement of it. So A union B is what we've shaded the blue circles in. So if it's complement, it's the opposite. So it's everything that is not in A or B. This is where you'll see the difference between A union B and A intersection B. So the top right hand question is A intersection B. And remember, this sign we can replace with the word and. So we want everything that is in A and B. It has to be in both for it to satisfy this. So it can't be this section here because that's not in B. So the only bit we can shade is the centre, because the centre is the only part of the Venn diagram which is both in A and in B. Next we've got A intersection B complement. So it's everything that is not in A and B. So it's the opposite of the one above. First of all, we can look at the symbol in the middle, which is a union, so we know that it's going to be or. The easiest way is to do these separately. So we know we've got A or B complement, which means not in B, and do them separately. So first of all, I'm going to shade A, and now I'm going to shade everything that is not in B. So again, we've got union, so we know that it's going to be or, and we want everything that is not in A, because we've got A complement, or not in B. So I'm going to start off by shading everything that is not in A. And now I'm going to shade everything that is not in B. There might be some overlaps, but that's fine. Next, we're going to look at intersection. So we've got the intersection symbol, so we know that it means and. Now, I've taught this so many different ways, and this way I think is the easiest by far to interpret these. So we need to be able to look at what these have in common. Now, a lot of you might be able to see these straight away, and that's fine, but I find the easiest way to do this is to just sketch two little Venn diagrams first, draw those in, and then we can compare them. So you can see here I've drawn two separate Venn diagrams. They can just be a sketch, it doesn't matter. And what we're going to do is first off look at the first section of the problem, which is A, and we're going to shade that region into this Venn diagram. So you can see I've just shaded the A circle because I just want everything that is in A. Next, I'm going to look at the second part, which is B complement, and I'm going to shade that in on this Venn diagram. So I'm going to shade everything that is not in B. Okay, so intersection means it's in A and not in B. So we are looking for something that they have in common. So if you look at your two Venn diagrams at the bottom, which sections are shaded in both of those diagrams? So I think it's a lot easier to see this way, and you can see that it's just the section there that is in the circle A but not including the centre that is in both diagrams. So that's the bit that we need to shade in on our main diagram. So we're going to do the same for this one. I've got my two Venn diagrams at the bottom. I'm going to shade A complement on the first one, and I'm going to shade B complement on the second one. So A complement means everything that is not in A, and B complement means everything that is not in B. Now we need to look at these diagrams and work out which bit is shaded in both of these little Venn diagrams. And you'll notice that it's actually the outside of both circles. So that's the bit we're going to shade on our main diagram. So we're now going to look at how this works with numbers. So you're going to start off with a universal set and then set A and B that you need to work out. So set A is all of the even numbers, and this is exactly the same as the previous video I did. So out of the universal set, the even numbers are 2, 4, 6, 8, 10, 12, 14. And set B is all of the prime numbers that are in the universal set. So that is 2, 3, 5, 7, 11, 13. And then as before, you just need to put these into the Venn diagram. So for the first question, we need everything that is in set A. So I'm going to shade in the circle of A, including the section in the middle. So set A becomes 2, 4, 6, 8, 10, 12 and 14. Next I want A complement, so I want everything that is not in A. So that is 1, 3, 5, 7, 9, 11, 13 and 15. Next I need B, so I'm going to shade in the circle B, which includes the centre. And then for B complement, I'm shading everything that's not B. Next we're looking at A intersection B. So this symbol here was intersection, so it means and, so A and B. Now, like before, the easiest way to do this is to have two separate Venn diagrams drawn. And then you're going to start off by shading in A in the first Venn diagram and B on the second Venn diagram. For A, we're just going to shade in the circle A, and for B, the circle B. Now, because it's intersection, it needs to be the area that is shaded in both of these diagrams, and the only bit that is shaded in both is the centre. So A intersection B is going to be 2. I'm going to do the same for the next one, so we're going to shade in B on the first Venn diagram, A in the second Venn diagram. What is in both? What is shaded? It's also 2. So B intersection A is 2, and you'll notice that they're actually the same answer. We're going to do the same here for A complement and B. So A complement is everything that is not in A, and B is the circle B. And then we need to look at what is shaded in both diagrams, and it's just the section of the B circle that doesn't include the centre. So A complement intersection B is going to be the numbers 3, 5, 7, 11 and 13. Next we're going to do the same for B complement intersection A. So on the first Venn diagram we're going to shade B complement, and on the second we're going to shade A. So B complement means everything that is not in B. And A, we're going to shade in the circle A. Next we're going to look at what is shaded in both diagrams, and it is just the circle A that doesn't include the centre, so our numbers are 4, 6, 8, 10, 12 and 14. We're going to do the same with this question. So on the first Venn diagram we're going to shade A complement, and on the second one B complement. A complement is everything that is not in A, and B complement everything not in B. And then we need to look at what's shaded on both diagrams, and it's everything that's on the outside of the circles. So A complement intersection B complement is just 1, 9 and 15. We're going to do the same for this one. We're going to just look at the one inside the bracket. So we're going to shade A on the first diagram and B on the second. So A is just everything inside circle A, and B is everything inside circle B. And as before, what is shaded in both? And it is the centre. But we actually want the complement of that. So we want everything that is not that. So we want everything apart from the centre. Okay, the same with this one. Apart from this is a union. So we're going to shade A on the first diagram and B on the second. But this time it's or. So we want anything shaded on the first diagram and everything shaded on the second, because it can be A or B. So basically, anything that's shaded on either of those diagrams, you need to shade in on your main Venn diagram, and it includes all of those numbers. Then we're going to do the same with this one, so we're going to shade A complement on the first Venn diagram and B on the second. So A complement is everything that is not in A, and B is everything in the circle B. And then we need to shade in everything on the main Venn diagram that is shaded on your two smaller Venn diagrams. So the only thing that will be left is the part of the circle A that doesn't include B. Next, we're going to shade B complement on the first diagram and A on the second. So B complement is everything that's not in B, and A is the circle A. Then we need to look at what is shaded in both of these diagrams and shade that on our main Venn diagram. So it'll be everything apart from the circle B that doesn't contain A, and then write those numbers down. Next, A complement and B complement. So we're going to shade in A complement, which is everything that is not in A, and then we're going to shade in B complement, which is everything not in B. Then we're going to shade everything on our Venn diagram that is shaded on either of the two Venn diagrams on the right, and that only leaves the number 2. So we're going to write down all our numbers that are shaded. Again, we're going to look at the brackets. So we're going to shade A on the first Venn diagram, B on the second, and then on the Venn diagram, we want to shade everything that is not shaded on our Venn diagrams on the right-hand side, because we want the complement of them. So it actually ends up being just the outside, which is 1, 9, and 15. For the last one, we need to shade A complement, which is everything that is not in A, and then B complement, which is everything not in B. Now, if I shaded that on the Venn diagram, that would leave me this. Now, we want the complement of this. So actually, I want everything now that is not shaded, so it is only the centre. So A complement union B, and then the complement of that is going to be just 2. Okay guys, I know this is a lot to get your head round, but pause the video and have a go at these. Some of them are tricky. If you're really not sure of them, write them down on the Wednesday or any day, just message me and we can go through them. Okay, so where does probability come into this? So if we want the probability of A, I'm going to shade in A. I've got 3 out of a possible 10, because 1 and 2 is 3. If I add all the numbers together, I get 10. If I want A complement, I want everything that is not in A. So this is all this shaded. And then I add together what I've got shaded, so that's 7 out of a possible 10. You can pause the video and have a go at the rest of these. Okay, there's loads of questions now coming up. I don't expect you to do all of them. Do them until you are happy, but I just wanted to put loads of them available so you really were happy with what you'd been doing.